In honors pre-calc. So I just wanted to go over a couple of things that we looked at today in terms of our properties and how you're going to be building this toolkit. So one of the things that you can do is start off and let's add a document, and let's call this document Math Toolbox. I'm just trying to get this quick video out for you for honors pre-calc. We'll just do HPC. Okay, so for this, one of the first things we talked about today was that absolute value. So with the absolute value, there was an inequality, and I think I mentioned the equation too. So if you have, you're solving, this is an equation, right? Not just the absolute value, but absolute value equations and inequalities. So one of the things that you could put on your toolbox is you have the absolute value of x is equal to a. Then I would say that that would translate to x is equal to a, or x is equal to negative a. Then I would say the absolute value of x is less than a. And you can always say less than or equal to. Then that double arrow means if and only if. If you have this, then you have that. They're equivalent. So then you have x is less than a. And I remember I said that same and then the flip. So, and this is an and statement. The absolute value of x is less than a, and x is greater than negative a. Now, for these, I like to use a number line. Actually, for all three of these, I like to use a number line. So with this one, the first one, you have negative a and a. Of course, you have 0 in the middle of this, right? So you have 2 points on a and negative a that represent the solution set, right? So then for the next one, we have negative a, and we put 0 in the middle. You have this set of values that go from, open circle, because we're not including the endpoints, and that represents the set of values between negative a and a. So what it's really saying with absolute value is it's the distance a number is from 0, right? So the absolute value of x is equal to a means that a is a units from 0 on the number line. So then you have the absolute value of x is greater than a, and then that's equivalent to, or if and only if, x is greater than a. So those three in that first column are all the same setup as the original absolute value, and we lose the absolute value when we write these. Or x is less than negative a. So on a number line, what that last one would look like, 1, 2, 3, here we have negative a to a still. And we'd have an open circle, but our number line looks like this, where we're going out on either side, where the absolute value of those numbers is greater than a. So that was the first thing that we talked about in the warm-up today. So then the next thing that we talked about was some rules for exponents, and we did some problems over to combine. So the first rule that I think I like to hit on with students is, remember, you have powers with the same base. So if we have powers with the same base, then we can multiply them and we can simplify them by adding the exponents. We would just add n plus n. A quick example of that would be, we'll just use a number first, 2 to the third times 2 to the 8th. Let's make that interesting, 10th maybe. And I'm just going on memory here. I think this is it. I think you get 2 to the 13th. I hope this is right. I'll have to check. I think it's 8,192. You can check me on that, okay? Not important, but you see where I added the exponents for that. Then you have another rule. You have x to the n over x to the m. So with that one, we're going to say that that is x. We keep the base, and then we subtract the exponents top down. So n minus n. An example of that would be if, well, I'm going to leave that one go. Maybe we'll give, you know what? Probably important that I do this. Negative 3, I'll use a negative number with this. Negative 3 to the 5th power over negative 3 to the 2nd power. So we get negative 3, we keep the same base, and then we just say 5 minus 2, where remember I said 10 plus 3 here, I just added it as 13. And we have 5 minus 2, so that's going to be negative 3 to the third power. And that, remember, is negative 3 times negative 3 times negative 3. And that then is going to be negative 27. So there's the answer to that. So then you had, I'm going to use A and B now. If you have A to the nth power, then we would have A, and A could be a number or it could be a variable expression, but we would have A to the n times m power. So we're going to multiply. And we had that happen in several of the problems that we did today. Let me move these up just a tiny bit, okay? So I'm going to leave that one go because the video is going to get too long if I do examples for everything. So this one is a power of a power, okay? We're raising a power to a power. And then if I take a product, AB, and I raise it to the nth power, then each one of the factors is risen to the nth power, okay? So if I then take and have a fraction like A over B, and I could use x's or whatever to the nth power, then that means that we're going to raise the top to that power and the bottom to that power, okay? And then if we have A to the negative n, and a lot of these, this would be then 1 over A to the n. If we had 1 over A to the negative n, we could rewrite that as just A to the n. Okay, so those sometimes come in handy. And if I have a fraction, like, say 5 over x, and that was to the negative third power, like that, then we could rewrite that as 5, x over 5, and we could write that as the third power. So the reason why we might want to do that is because sometimes negative exponents throw us a little, and we very often want to write in terms of positive exponents. So the rule that we would have here is we would flip the fraction b over a, and then we would write that as to the nth power. So these are most of the important ones that you come across. So you have all these that you're going to want to put in a toolkit, okay? There's just a quick example of that last one, okay? Now, the next thing that we ran into was factoring. So on, let me see, multiplying, factoring. So I think multiplying polynomials. So when you multiply polynomials, let's start off with, what you're going to do is, let's take, for instance, I know what to do. How about if I do P plus L times A plus N, like this. So what I'm going to do is I'm going to multiply the first. This is your first in your FOIL. We often use FOIL, right? This is one thing. But all we're using is the distributive property. So if I multiply P times A, and sometimes we just put the letters next to each other, plus then we multiply, here's the outer, so first outer, that would be then P times N, plus here's the inner in the FOIL, that's L times A, plus, and then the last is L times N. Okay, so you get these four terms. There are no like terms, so we're not going to simplify those at all. But you know what I just did? I foiled your plan. I foiled the plan, or whatever. Okay, so multiplying polynomials. So if I have something like 2 plus x times x minus 3, keep in mind, you don't have to have the x's first. You could multiply them just the way they are. So we'd have 2x plus, then, see, I'm following the same order that I had before with the FOIL. 2x plus negative 3, we'll just write that as minus 6, and then plus x squared minus 3x. So it'd be plus x squared, and then minus 3x. So in that we would simplify by and I'm going to write this in descending order, starting with the x squared x squared, and then I'm going to add the 2x minus 3x, giving me minus x, and then I have the minus 6. Okay, so for that expression, I've multiplied it, and this is what I get for my answer. Okay, so I've simplified the polynomial. Now, very often, say if I had x minus 1 times x squared minus 2x plus 6, or 3x, who cares what it is. Now, I could do the same thing, and I could go multiply the x and get those terms, and then multiply the negative 1 and get those terms, and add them all up together. That's essentially what we did there. But one of the things I find that people like to do to keep them organized, if you need to do this, it's just a way. Oh, what happened to my rectangle? I don't think I'm going to get a rectangle that time. But, okay, so if I divide my rectangle into 6 cells, and on the height, I'm going to write x and a minus 1. I'm going to make this a multiplication table. And then I'm going to make x squared minus 2x plus 6 there. And I'm going to multiply each of the terms for the cells where these two meet. I get x cubed, and you can get the idea then. X times negative 2x is negative 2x squared. X times 6 is 6x. X squared times negative 1 is negative x squared. And then negative 2 times negative 2x times negative 1 is 2x. And then negative 1 times 6 is negative 6. I'm going through this quickly. I'm hoping I don't make any mistakes here. So we start off, we list the highest degree first, so that would be here. And then we add these two terms. We get negative 3x squared. And then we add these two terms, 2x and 6x. So that's going to be plus 8x, and then minus 6 would be our answer. So again, I'm running through this pretty quickly so you can get the idea here after not being in a math class for a little while. And you can do the same thing with FOILing, making a table with it's a 2x2 table, okay? Now I need some good factoring problems, so I'm going to skip out of this for just 1 second. I'm going to pull one up here. So I have the Unit 1 review here. So where we left off, we had adding like terms. I think you guys are good on that. I don't think you really need to go over that. I think the multiplication. One thing about this problem, number 6, you can see I set the answer up there. So when you multiply them, I multiplied to get the answer for the two binomials in the n in yellow. And then I went ahead and multiplied it by the 2r minus 5, again, to get the final answer, okay? So you can go over that. I'll be submitting these answers tomorrow, but I'll let you try those. So it was the factoring problem. So hang on 1 second. I'm going to completely factor this problem. So I'm going to copy, and let me go back here to my note. And so in this case, paste. Oh, no. Let me paste image. Yes, we win. Okay, so the instructions here are factoring. So the first thing you want to do when you factor polynomials is you want to look for, is there a GCF, a greatest common factor between the terms? So that would be the topic that we're dealing with here, factoring polynomials. Let me see, scooch this down here a little bit. Here, wait. Can I move that down? Oh, I'm taking my while. I'm just going to leave it, folks. So GCF. So the GCF is then going to be the greatest common factor of all three terms. I can see the 12, 26, and 10 are all even. So I'm going to say there has to be a 2. There's not going to be a 4. There's not going to be a 5. Just 2. So now I look at the lowest variable factor of W, and that's just W. So you can't pull out what's not there at this stage. So we're going to pull the 2W out front, and then we're going to do reverse factoring. Say 2W times what gives you the first term, 12W cubed. So in that case, then that's going to be 2 times 6 is 12. So it's going to be a 6, and a W times a W squared will give you 12W cubed. 2 times 13 will give you 26, and then W times W will give you W squared. Minus then 2 times 5 will give you 10, and we already have the W factored out. Okay, so it's like that. Now what we want to do is continue to factor if we can. So now the topic is factoring a trinomial. Now there are different ways trinomial. So in this case, you have 3 terms. So you're looking for 2 binomials, if you will. Okay, so 2 binomials is what you expect to factor. okay? So we'll leave the 2w out front, and then we'll set up the 2 brackets here. Now, the way I do it, when 5 is prime, the only possibilities, what I say is, okay, the first term is 6w squared. The last term, because you realize that the first is going to give you this number, this term, 6w squared. The last product, okay, that's the first. The last, L-A-S-T-S, that's hard to say. The last is going to give you a -5. So what's easy about this one is that -5 is equal to -5 times 1 or 5, +5 times -1. There's no other choices for that. So it's prime, right? So 5 times 1. And so I do a little guess and checking with this. The only possibilities for 6w squared are 2w times 3w and 6w times 1w, if you will. Okay? So I'm going to try the 2 and 3. The reason why I'm going to try the 2 and 3 is 3 times 5 is 15. So I'm thinking 13 is pretty close to 15. Let's see if we can get there. So I'm going to do this. I'm going to say, okay, and I'm going to do a reverse FOIL check with the outer plus the inner, because I know the outer plus the inner, when I do the FOIL, has to equal 13w, right? So I'm going to put the 2w here and the 3w here. Now, you guys have your method. You're splitting the middle factor, if you like. When the constant is prime and there aren't that many factors, I like to give it a whirl. Okay, so now I've got to decide. See the 3? I want to match that up with the outer and the inner, so I have to do these. I want the outer and the inner to add up to 13w. So I'm going to put the 5 here to give me that 15. I'm going to put the 1 here. And notice that gives me a 1 times 2 on the outers. So that gives me a 15w here. And the outers is going to be a 2w. So now I just have to put the right signs on here. I know that my factors are going to be -1 or... -5 and 1 or 5 and -1. I just have to assign them the correct way. It is going to need to be +5 to get that 15w and then -1 to subtract off the 2w. So that's the way I handle it. It factors very quickly. So the factoring for this one will be 2w times 2w plus 5. And this is on your worksheet. You'll be able to do that. And then we have 3w minus 1. So I might try one more, zipping over to, because factoring is sometimes an issue with people. So whenever we see, back to this one. So number 5, do you notice when we multiply those using FOIL? We got this. This is 5 squared g, here, let's do it like this. This is 5, holy cow, come here. 5g, the quantity squared minus 11 squared. That's what that turns out to be. So if I were to factor the final answer and go backwards, this I would get -5g plus 11, -5g minus 11 as the two factors, because this is the difference of two squares. So when we notice that we have perfect squares involved and it's a difference of just two terms, we have a rule for that, okay? So you notice, let me see where I got that. That one is the one we just left off, and I think this is the one that I want to do. So let's snap this one and copy that. I think this is going to be the last one, and then I've got one more factoring by grouping, and you can look at the answers that I have for number 11 below then, okay? Remember, tonight I want you to do your level best at getting some of this work done. I know that you're coming into a class for the first time, so remember, have your questions ready and move along as far as you can. So this is another problem from your homework. So if I'm looking at this, the first thing I'm going to do is notice I have two terms. Now, with two terms, the only possibilities is that you have a special factoring, you have a GCF factoring, and you ask yourself, do you have that? And you don't. So then you have the difference of two squares, and it's not really obvious. And then you also, but you see where you have c to the 4th and d to the 6th? Those are perfect squares. And 64 and 121 are perfect squares. So one of the things I have students do in an Algebra 2 class is I have them get used to the perfect squares. So they'll make a list of 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and they continue to make a list until they get up to 144. That's 12 squared. Okay, so they recognize when they see them. And then whenever they see a power that has an even exponent, that's going to be a perfect square. So let's look at what the rule is for the difference of two squares. I'm going to zoom in here. If I can write a two-term expression as a squared minus b squared, then that will factor as a plus b times the quantity a minus b. Okay, so that's what I'm looking for. And then that will be called the difference of two squares. Okay. I have a place that I have to be, so I want to see if I can get this done quickly. Okay, so I need to write it in this form, and it's apparent to me that I can. So I'm going to say, all right, let's see. I'm going to write it as a square minus a square. So if I look at that, 64 is 8 squared. So if I write this as 8, and then c to the fourth is c squared squared. Okay, because remember, when I square 8c squared, I get 64c to the fourth. And then 121 is 11 squared. So I'm going to write the inside of this square as 11, and I'm going to write it as d cubed. So now I have the form. So what I'm going to do is move this over. Oh, no, I'm not. Here. I don't think I can grab that part of it. Nope, I can't. Okay, so what I'm going to do is I'm going to put this under here like this. A squared minus b squared. Okay, so I want you to look at the rule over there and follow along with me. So this is equal to, then, a plus b, a minus b. So in this case, what I'm going to do is I'm going to say, what is a? Well, a in this case is 8c squared, and b is equal to 11d cubed. Okay, so I'm just going to pop them into the binomials, a plus b, a minus b. So my binomials are going to be 8c squared plus 11d cubed times the quantity 8c squared minus 11d cubed. And that, my students, is the factoring form that we're looking for. We have factored the binomial expression that is the difference of two squares. The other one, I have time to do one more. There was one more with the sum of two cubes, and there are two formulas that I want you to know. And let me see if I can take this off. I'm going to try to finish this key tonight. Oh, messed up there. Let me see if I can get all of this. And that's the formula that you see. Oh, I didn't want to duplicate it. I wanted to copy it. Copy, and let me come over here to the note. So let's take this one. So paste image, and oh, I missed the first part of it. So, oh no, I got it. That's it. Everything's there. So let me make it a little bit bigger. And so I did have, here's the sum of two, this is the sum of two cubes. So that is another binomial expression. So that's the sum of two cubes. Okay, that's the formula. And I always help students to remember it by doing the following, where you have, here's a plus sign here, right? This is a plus sign, so that is the same. This one is opposite. Oh, let me change color here for just a second. So I have, this is a plus sign. This is the same. This is opposite. And then this last one is plus. It's always plus. So I call it the SOP method. So when we get done with this, I'm going to show you another formula that's very much like this, the difference of two cubes. So you're going to rewrite this as the sum of two cubes. Okay, so what I'm going to do is I'm going to scooch this over. Might as well save time. Oh, I keep doing that, right? Here. Can't seem to do that there. Let's move it over so it's right underneath the formula. Cube plus. Okay, so there's the left-hand side. So I need to isolate. So I'm looking at the first term. So I've got 27r cubed. So that's going to be 3r cubed. Now think about that. When you cube that, you're going to get 3r times 3r times 3r. And then 216 is, of course, 6 cubed. So what I do is I'd say, well, my A here is 3R, and my B is 6. So in order to factor this, all you really have to do is say, okay, that's 3R plus 6. Then I have 3R squared. I'm going to go ahead and write it as the square, minus A is 3R, so it's going to be 3R times 6 plus 6 squared. Okay, so my factoring for this sum of two squares is 3R plus 6 times 9R squared minus 18R plus 36. And in that one, because we have a common factor, we can actually factor more out than that. It was just the way that I happened to grab the two terms. I actually should have factored something out, but I didn't because I happened to see the perfect cubes first. So we could factor a 3 out, and we get R plus 2. And then we can factor a 9 out, and we get R squared minus 2R plus 4. So we get 27 times R plus 2 times R squared minus 2R plus 4, bada, bada bing. And for you Mandalorian fans, I hear March 1st is the first show of the second season of The Mandalorian. Or is it the third? Oh my goodness. I hear it's coming out March 1st anyway. So it's one of my favorite shows. But anyway, so there you go. There you have it. There it is. And if you happen to be hearing this years later, you'll be like, Mandalorian? That came out a long time ago. So here's one more thing, is that if you have A cubed minus B cubed, if you can set up your two terms as the difference of two cubes, it's really the same way. But you're going to say A minus B, so it's the SOP method still, times the quantity A squared plus opposite sign AB, and then plus B squared. The B squared term is always going to be positive, so the SOP method help you to remember how to set up the terms, okay? So that's it for tonight, kids. So good luck going over some of the rest and just refreshing yourself with the pre-calc, just the algebra that you've learned in the past. Sometimes it's a little hard getting started, but hopefully this review will help you a little bit. All right, have a great night. I'll see you tomorrow.